The Earth's precession rate is 1.4 degrees per century. How many years does it take the Earth's axis to precess by 1 degree? The easiest way to lay this out is to think of the degrees and the time. So in the question it tells us that the degrees is 1.4 degrees per century, 100 years. We don't want to know how long it takes for 1 degree, we want to know 1 degree. So to do this we need to think about, well, what do we need to do to turn 1.4 into 1? Well, we will divide 1.4 by 1.4. So we need to do the same to the other side. Dividing 100 by 1.4 gives us 71.4. So the answer is it will take 71.4 years for the Earth's axis to precess by 1 degree. An ancient monument was constructed so that on the date of the summer solstice, its stones would be aligned with a certain star. The alignment of the stones is now 30.2 degrees from the star. The average rate of precession is 1.37 degrees per century. Calculate the approximate age. So again, we can use degrees and time. Now it tells us in the question that 1.37 degrees of precession takes 100 years. But we don't want to know 1.37, we want to know 30.2 degrees. So what do we need to do to get from 1.37 to 30.2? So dividing 30.2 by 1.37 shows us that we need to be timesing by 22. So therefore we need to do the same over to this side. Obviously this number is slightly rounded, so if you do it on your calculator you get 2,204.37 years. So rounded to the nearest year for the moment, 2,204 years. Again, a similar question here. So it says archaeologists estimate that an ancient stone monument was constructed circa 700 BCE. Some of the monument's stones were aligned to the Pleiades, which is a star cluster in the constellation of Taurus. The average rate of precession is 1.4 degrees per century. So I'll put that information in. It says the stones are no longer aligned with the Pleiades. Estimate the angle by which the stones are now misaligned. So we're currently thinking how long has passed since 700 BCE to the current day, which is 2023. So to work out the difference, we know there's been since year 0, 2023 years, plus the 700 before the Common Era, so we're talking a time scale of 2,723 years. So we need to know how long does it take to go 2,723 years. So we would need to be multiplying 100 by 27.23. What we're actually saying here is 27.23 centuries have passed. So we would also do the same to this side. So timesing 1.4 by 27.3 gives us an angle of misalignment of approximately 38.1 degrees. The Earth's precession rate is 1.4 degrees per century. Express this rate in arc seconds per year. So we've got our measurements in degrees per century and we want it to be in arc seconds per year. So we're going to take these one at a time. So we know it's 1.4 degrees per century. That's saying it's 1.4 degrees per 100 years. So let's firstly sort out the year. So we know if it's 1.4 degrees per century, if we divide it by 100, then that will give us the amount of degrees in 1 year. So doing 1.4 divided by 100 gives us 0.14 degrees per century. So per year. So we've fixed half the problem. Now we need to deal with the other side. So we know that 1 degree is equivalent to 3,600 arc seconds. So we don't have 1 degree, we have 0.014 degrees. So what do we need to do to turn 1 degree to 0.014? Well, we need to divide by around about 71.4. And we do that to one side, we will also do that to the other side. 3,600 divided by 71.4 gives us approximately 50.4. So we know that the rate of precession is approximately 50.4 arc seconds per year. The precession rate of planet Trascom is 1.1 degree per century. How many years does it take Trascom's axis to precess by 30 arc minutes? Well, there's a nice thing that we could do here, because we know that 30 arc min is equivalent to 0.5 degrees. The reason being, there are 60 arc min in 1 degree, and so obviously half of that would be 30 arc min, so it's half a degree. So we know that there are 1.1 degrees per century. So there's again our degrees and time, but we don't have 1.1, we have 0.5. So to get from 1.1 to 0.5, we need to divide by 2.2. So we will do the equivalent on the other side. 100 divided by 2.2 gives us around about 45.45. So we would run that up to 45.5 years. The axis of planet Utkor precesses by 0.95 degrees per century. Express this value in arcsecs per year. So again, we've got degrees and time. So our degrees is 0.95 in 100 years. So we will firstly change that into 1 year. So we know we need to divide by 100 to get rid of that. So then that means it's 0.095 degrees per year. And then we need to convert our degrees into arcsecs. So we know that 1 degree again is equivalent to 3,600 arcsecs. That's degrees. But we haven't got that, we've got 0.0095. So what do we need to do to get from 1 to 0.0095? We need to divide by around about 105. So we would do exactly the same over to this side. And doing that gives us approximately 34.2 arcsecs per year. So hopefully you had a go at those questions and you found out how to do them. Have a go at the Kahoot to see if you can do even more. Good luck.